force, types of force, and effects of force. Okay.
We didn't get to really but we didn't get to really use Scratch. We only did it for like 10 minutes or maybe
Yeah,
15.
actually, Scratch is not my subject. I just know a little bit about it, so
Oh,
I
okay.
think, yeah. Okay. Can you see my screen?
Okay. Yeah.
So basically, let's start with some real life example. What does a footballer do to move a football? Tell me.
He throws it. He throws it.
Throws it? Football.
Yeah.
Hmm.
Yeah.
You mean he kick?
Wait, where was this made? Where was this made?
Which what made?
This. Was it made from like Puerto Rico, South America, something like that?
No.
It's just
Like, I mean, like, okay, cause if it's talking, it might be talking about soccer or football, like with the football.
It is
Cause in
football.
America, cause in America,
Hmm.
there's this thing called a football. It's like brown. It has stripes.
Okay.
Can you search up football?
Yeah,
Let
yeah.
me show you.
No,
Wait.
no. Can we just stick to the topic, please? Because then I
Okay.
don't.
Cause I don't know which one. Cause there's a soccer ball and then a football.
Okay, any ball. How do you move a ball? This is my.
I normally you can throw it
Yeah. So basically, and how does a goalkeeper stop the moving football?
by catching it.
By
By
catching it.
catching it.
Exactly. How does a player changes the direction of the ball?
Okay.
By like if a ball is coming, how does a player changes the direction? In
He throws it,
yeah,
kicks it, hits it, or something
exactly.
like that. Look at
So
the chat. I showed 2 pictures.
and so see when I'm teaching, please try to be on my screen, okay?
I am.
Okay. So you okay.
Yeah.
So
One of them is a soccer ball. One of them is a American football.
okay. Which one is which? Can you please define like this blue
So,
one is what?
soccer ball.
Okay. So football is
And
of
the
this
other
this
one,
shape?
wait, what? Show me. The football is the brown one.
Okay. Oh, okay.
And the game is called football.
Mhm.
In some parts of the country, they call soccer football because use your foot to kick the ball.
Yeah.
But in America, they call it soccer ball. Soccer.
Oh, okay. We call it football actually.
That's why I didn't know which one.
Okay, okay.
Okay.
Now you know, right? So
Yeah.
basically, like you said, we kick it, we throw it, we hit it. So flicking, kicking, pushing, all these things are nothing. Basically, what we are doing here is we are applying force, right? It is generally
Force.
said
Yeah.
that these people are applying force when they are kicking the ball, footing the ball, pushing the ball or flicking the ball, right?
Yeah.
So what is force? Force is push, pull, or kicking it, kicking something, any object, or hitting, right?
Yep.
So tell me, what is force?
Hitting, kicking, flicking,
Hmm.
throwing, and touching. Mostly touching. You have to touch it and then do something with it. Like I can, if like with my computer, like
Mm-hmm.
I can get this blanket. Oh wait, let me take off my thingy.
Mm.
Background.
Can you please remove this background? Okay.
You can do this.
Yeah, this is also.
I grab it, I
Mhm.
grab it, and then I put it up, down, left, right.
Yeah.
And then if I slam it, something like that.
Okay, great. So you see there are some
I like my
pictures.
background.
So okay. So
Yeah.
what do you see in these pictures?
Everybody's using force, like pushing, pulling, kicking, dragging, and punching.
Very good. So what do these activities lead to? Like if this girl is pushing the
Using
trolley,
force.
the trolley will
Move.
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 Exactly. If this guy is punching a bag, the bag would
Move.
move. Exactly. Similarly, this boy is kicking a football, so the ball would move.
Move.
Right? Yeah, so that means
What about pulling a dog?
yeah, the dog would also move, right?
Yeah.
Or dragging a luggage, so luggage would move. So basically these activities are leading to motion, right?
Yeah.
All of them. Yeah, all
Yeah.
of them are leading to, so all these activity lead to the motion of an object.
Okay.
So actions like such as opening, closing, punching, flicking, hitting something, lifting, pressing, all these are used to describe certain task and the
Using
result.
force.
Yeah, we are using or applying force on object when we are hitting it or pushing it or pressing it or whatever. So now
Yeah.
and it leads to change the state of the object. Like if the object is at state of rest, it will rest means not moving, it will change it into state of motion.
Yeah.
Are you doing something on screen? Are you on my screen?
No, I'm here.
I mean, are, are you on some, like are you searching or doing something else, or are you on my
No,
screen?
I'm on your screen. Hello.
Okay, good.
This guy punched that bag. He has
Yeah,
muscle.
yeah. So
Line. Yellow.
so here this kid is writing using a pen on the notebook. So here who
Yeah.
applies force on whom when he's writing on
He's
notebook?
writing.
Yeah.
So I think the pen is putting force on. No, the child putting force on the pen. The pen is a slave.
Okay. The child pushes the nib of the pen on a paper while writing. He is also dragging the pen
Yeah.
while writing, right? So
Yeah.
that is also pulling.
I feel bad for the pen. Feel bad for the pen.
Okay. So
Pen
basically
pulls.
he is pushing or pulling, that means he is applying the force, right?
Okay. Yeah.
So can you read first one and tell me what you should put in
Actions.
the blank space?
Actions such as opening, closing, punching,
Punching.
flicking. Yeah, I try to finish punching, but I yawned.
Okay.
Punching, flicking, hitting, lifting, picking, pressing, pulling, bouncing, and pushing are used to describe certain tasks and result in the application of
Application
movement, a movement on an object.
of a force.
Force on
These,
an force.
yeah. So basically,
Force.
yeah. So now we have seen. So what is force? Is that clear? What is force?
Yeah.
Okay, now let's see what are the effects of force. So in first
Okay.
picture, there is a guy, and this boy is just standing near a football. So will the ball would move if he's just standing near the ball?
Technically, yes, because the wind could push it or someone else could kick it, but just him there? No.
If I ignore the wind and all, then it is just until and unless he apply any force, any external force, um, otherwise it won't move, right? In second one,
Yeah.
when he applies force on the football by kicking it, it will start, what will
To
happen in,
move.
yeah, it will start moving. So that means first effect of force is that it can move, it can make a body move. A stationary body, what is the meaning of stationary body?
Like a body that can't move without something's help.
Yeah, a body,
Without
yeah,
something else helping it.
yeah, a body which is at rest, which is not moving.
Yeah. Okay.
So what is the first effect of force? It can make a stationary body
Push.
move.
Oh, yeah.
Now, what happens when a goalkeeper catches the ball?
The ball stops moving.
Very good. And what happens when a fielder catches the cricket ball?
It stops moving.
Yeah, it stops moving. Good. So basically, that means the second effect of force. Can you guess what is the effect of force from here, this example?
Pull.
Okay, that's force. I'm asking what is the effect of force, what it can do.
It can stop.
Very good. It can,
It can
that's what I
stop
wanted to listen.
it.
Yeah. So that means a force can stop the motion of a moving body, right? When it is applied in the direction opposite to the body's motion, right? The direction should be opposite,
Yeah.
because like if the ball is going towards right, he would apply force in the opposite direction to stop it, right?
Okay. Yeah.
Okay, that's great. Now in first picture you can see when a so what happens when a boy standing near a football kicks it?
Um, he, um,
What
nothing
happens?
happens. The ball just stays.
No, when he kicks it, then
Oh, it moves.
yeah. What happens when he kicks it harder?
It moves even harder. So like
Yes.
zoom.
Yeah, like you kick. Hmm?
No,
Okay.
I
So,
kick. I'm like this. I'm like the first one. I don't play soccer.
okay. You don't play?
Yeah.
Okay. So the speed of the football increases, like you said, the football will speed up even further if he kicks it harder, right?
Yeah.
So from here, can you tell me what is one more effect of force?
Move. Like movement. It can make something move. Stop.
Okay, yeah, but we are anything else?
It can make it go faster.
Very
It
good,
can make it go slower.
very good, very good.
It can go.
Exactly,
It can make it go higher. It can make it go
exactly.
lower. It can
That's
make it
what I
go to the
wanted to listen.
side. It can make. It can make it to the left side. It can make it to the right side. It can go to the right diagonal. Left.
Very good.
No, it could go to the upper corner diagonal. It could go to the left upper corner.
Mm-hmm.
Up diagonal. It could go to the left lower. The right lower.
Mm-hmm.
Yeah,
That's
that's all I
great.
have.
You already covered my upcoming slides. That's great. my smart
I
student.
did. Can
Yeah,
I see? I
yeah.
want to see. I want to
Because
see the other side.
because you said it can go left, right, and that was the next. See, the direction changes. See, when you like with the help of force, you
Oh
can
yeah,
change.
Karen board, so much fun. We have our own Karen board.
Uh,
That's
yeah,
such a good game. Karen board's
we
so much
also
fun.
have that. Yeah. So yeah, that means a force can speed up the motion of an object, like you said, or it can slow down the motion, right? Like
Yeah,
mhm, when we apply brake in a car, its speed reduces, right? So
yeah,
the car gradually slow downs and eventually it stop moving, right? So that
yeah.
means a force can slow down the motion of an object, but when it will slow down, when it is applied in the direction opposite to the direction of motion. Next, like you said, like here, when hit by a bat, a baseball changes its direction. Similarly, when hit by an edge of a carom board, the striker changes its direction, right? So,
Yeah.
hmm, hitting is nothing but force. So that means what force can do? Can you read this written in yellow?
The force changes the direction of motion of a body,
Why are you
of a
yawning so much?
moving
Are you feeling
body.
sleepy? Hmm? Sit
No.
properly. Are you lying?
Okay. Nope. I'm on my chair.
Okay.
Look.
Yeah, remove the background.
Okay. Fine. I'm on my couch.
Yeah. So basically, in all these effects, there is one thing common. Tell me what is that?
Hmm.
Did you notice something
It
common?
moves.
Very good,
They
absolutely correct.
all use for.
Very
Wait.
good. And all of them
Stopping
are
it
moving.
doesn't move.
But yes,
Stopping it isn't moving. It stops it.
yeah, stopping is not moving, but most of them, except that one, if we apply force on any object, it start moving. Um, so basically, but the question is, will it always move? Like if you apply the
No.
force on the, if you the push the wall very hard, you apply all of your, you use all of your energy, you are pushing it really hard, would you be able to move the wall of your room?
Yeah.
No, right?
You could pull
Similar,
it.
could you?
Technically, yes.
What if I just ask you to show me the live experiment?
No, like, I could push it. All I have to do is make robotic hands that are extremely strong but don't break wall, only pull stuff. So I
Okay.
could get the wall and go like, and pull.
But I'm okay, that's not your hands.
I could drink a secret serum just like Captain America and become super pull. I'll
Oh
become
my
super
god.
pulley man, and I will pull it.
You have the answer to all
Yeah,
of the problems.
yeah.
So okay, yeah. So basically, the wall will not move if you push with your hands, you know.
Oh,
So a heavy loaded
well,
trolley,
I will prove you.
if there is a trolley which is very heavily loaded and you pull it really hard, would you be able to pull it? I know, no.
I think, yeah.
I knew you were going to say that. Okay, now I
Move
will
what?
move the
Wait,
trolley.
move what? Move what? That trolley? I can move a trolley.
Hmm.
With the thingy? Oh, a heavily loaded trolley. What if I put a 1 billion feathers?
Okay.
It's heavily loaded.
But the feathers are light, so it is lightly loaded.
No, there's lots of stuff.
Yeah, heavily means heavy stuff. Okay.
Oh.
Next is heavy dresser. If you push it, would you be able to move a very heavy dresser? Like in third picture, this one.
Harsh. When I become an adult, yes.
Okay. Okay, then I think, okay. But now,
Maybe.
okay.
Maybe.
So that means
Just maybe.
I can't hear no from your mouth.
Maybe. Maybe.
Yeah, so
The only
basically,
time you can hear the only time you can hear the word no is if you can give me something that I want.
okay, you are so smart.
Yeah.
What if I gave you the test?
That I want. I don't want that.
Okay.
Who said I wanted that?
Okay, let's come back to this. So, you won't be able to move the heavy steps. Why? Because the amount of force is insufficient to do so. When you are applying the force, oh my god, when you are applying the force on the wall, the force is insufficient to move the wall, right?
Yeah.
Don't,
Is this the test? Is
no.
this the test? Okay.
I will
Well,
be
I
take,
already had the answer.
I will be taking the test soon, no problem. Okay. Uh,
No.
so,
The test shall be in 5 billion years.
so
If you
you
put
will
it,
be gone. I mean, I will be gone too
no, you won't.
in five.
I'll do my test somewhere.
I can take that in heaven.
Yeah, sure. Wait, I still have to do my test.
Yeah.
I want to do my test.
You said after 5 million years you can take, so I will take
5.
billion
Oh,
maybe.
wait, I'll be alive. I'll be alive forever.
Okay.
I'll have a wish.
So yeah, so why we can't move these heavy objects? Tell me what?
Because they're
Don't scroll
the
and do all
normal.
those stuff. Just be on my screen, okay? I can.
I think you would be able to. I'm looking at you right now, just saying. If I look here, because my computer screen is here. I look this way. Ta-da!
Okay. Yeah. I
Okay,
ask you some
so
question. Yeah. Tell me why we are not
okay,
able to move.
so some people, not me, some other people won't be able to move them because they're weak.
Let's suppose that I know the name. What you are going to say? Some other people. Hmm? Are you talking about Jay?
No, actually, I was not thinking about that for once, but now I am.
Okay.
Thank you for the idea.
Okay. Okay. Don't tell him. Okay.
Now I will.
No.
No, I'm sorry. You have to do one thing. All you have to do is give me one Robux gift card. That's all you have to do. The problem is you can't do that.
I won what class?
Robux gift card. The problem is you
My
can't do
God.
that.
No, I can't.
I
Obviously, I.
know. If you could, you would be able to. If you could, I bet you would do it.
Mm. Okay, let's come back to the topic. So,
Okay.
um, yeah, so we have seen because uh, a object starts moving when we apply force on any object, when the force is sufficient enough to move it, right?
Yeah.
So, but when the force is not enough, we won't be able to move the object, right?
Yeah.
So, now let's talk like here there is a guy whose name is Sam. He's pushing this heavy dresser alone. Now his friends join him, Harry. So now they both, Sam and Harry, they both are pushing it together. So which of these is easier?
Pushing it together
Yes, why?
because people need help sometimes. Unlike me.
Hmm. Okay. Sigma, Pranav.
Yeah! It's actually Sigma PC, but whatever. You still got it.
Yeah. So, in which why it is easier, because there are two people and they both are applying the force in the same direction. This is really important.
Yeah.
The direction is important, because when we apply the force in the same direction, the effect of force increases, right?
Yeah.
Hmm. So why? Because the force add up. Like the forces of these two guys add up now, and there would be more
Yeah.
force. More force means it would easily move. Hmm.
Yeah.
So basically, the unit, like we measure the length in meters, kilometers, the weight in grams, kilograms. So similarly, we measure the force in Newton. You must have heard the name of the scientist Newton, right?
Yes, Isaac Newton.
Yes,
Yes.
Isaac Newton. Very good. So from his name, we got this unit, which is Newton, and capital N. Can you see this capital N? Um,
Yeah.
here, so this capital N is for Newton, like 95 Newton. So Newton is the unit of force, because he knew, like Isaac Newton, the scientist, he discovered the gravitational force, and he gave many laws, and also because he discovered the force, that's why um, uh, the 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 unit is on his name. Okay.
I have a good idea. He should have been named for grams. Because if it was grams, his name would have been more popular.
Okay, yeah. When we are going out, so every time we would be saying Newton, Newton.
Look at that Newton.
I want 5 Newton of apples. Apple, you know, Apple and Newton has
Apple.
have a connection.
They do. Yeah, they do.
Because of that,
Um. Wait. If orange and apple's name were mixed, like grass, right? Grass was actually water, and then water was grass.
okay.
Trees and seaweed. Seaweed was trees, and trees were seaweed. Bum 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 bum. Brain with heart. This is my heart. This is my brain. Hmm.
And Pranav
This is
is J.
people. This is people. That is human.
Oh my god.
The two
Okay.
men, that's
That's
human.
that's
The one
crazy.
person is people. Not plural, switched.
Okay, okay. I'm confused.
Chrome and Microsoft are switched.
Okay. Let's get back to the topic. So you can.
Computer and tablet are switched. Okay, let's start.
So in, you can see, suppose Sam applied 30 Newton of force on the dresser, and the dresser starts move, but he is finding very difficult to move it because the dresser is really heavy. So
Move it.
he call his friend, and Harry is one of his friend come and he help him. So Harry have more
Well,
strength. Okay, Harry have more strength. He is stronger than Sam, let's suppose, and he apply a lot of force. How much force he is applying, Harry?
hmm.
That's
Harry is applying
that means you were not on my screen.
65 Newton.
65 Newton. Good. So they both
Dun
are.
dun 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 dun.
Hmm, so they
From
both.
now on, just to make sure you think I'm not on your screen, I'm just gonna take 5 seconds to answer the question.
Okay,
Just
that's
5.
that's good. So they both are applying force in same direction. The force would add as,
Yeah.
so that means the force depends in how much force is there in first case.
Oh. Uh.
What is the force?
30 Newton.
Good.
30 Newton.
Yeah, what is the total force in second case?
Wait, 1 sec.
You
I got it. 95 Newton.
95 Newton. I can understand from your smile from where you got it. Okay, so the total force on the dress. How did we?
Oh, I can't do it. I'm trying to like make an act. I got it from adding 30 and 65.
Very good. Is called the total force is called the net force. Net means
Yeah.
combination of all the forces which are being applied on an object. Okay, when it
Yeah.
is more than one.
Okay.
Now
Yeah.
let's suppose, uh, let me take this whiteboard.
Achoo. I want a whiteboard. I want a whiteboard. I'm gonna whiteboard your whiteboard.
Okay.
Don't say. I
Yeah.
whiteboarded your whiteboard. But now I have the whiteboard.
This, let's suppose Harry comes and he apply the same amount of force, which is 30 Newton, in the opposite direction. Will the dress?
Hello.
Yeah,
Hello.
tell me, would it move?
You. Mm.
Can
Still no. Because they're weak and because both of them are going like this.
very good, because both of them are in opposite direction. One is going
And
toward.
because they're both weak.
They both are equal also, right?
Yeah.
So
But they're both weak. Like even the one guy just 30 Newton. If you didn't on both, they're still too weak because they're doing it that 60 Newton wouldn't be enough because that's too weak.
okay, but the main reason is that the direction are in opposite, the directions are opposite. Also the
Yeah.
forces are same. When the directions are opposite
Okay.
and same amount of force, it will cancel out each other. They will
Okay.
cancel out each other. Yeah. So
Okay.
for example, so that means when forces are applied in opposite direction, they cancel out, like 30 minus 30. When forces are in opposite direction, the net force we get by subtracting them,
Yeah.
like 30 minus 30 is 0. So the net force is equals to 0, right?
Yeah.
Yeah, and in this case, why we added and we got 95?
Yeah.
I'm asking
But
you. I know you are not there.
I am. It
Mm,
was a joke. Don't you understand the joke? I
I
said
understand.
5 seconds. Did I do more than 5 seconds? I'm very sorry. So, the Newton would be zero because
What?
it wouldn't work.
I didn't
But
ask you this.
then what did you ask me?
I'm
You said 30 minus 30.
no. I'm asking why we added the force here. Like why we added 30 and 65.
Because if you did 30 and 65 just by itself, it wouldn't make sense.
No, because the forces are in same direction. That's why
Oh.
we are adding. When the forces are applied in the same direction, they added up.
Okay.
But in this case, the forces are in opposite direction. That's why we subtracted them.
Yeah.
Okay, very good. And in this case, the net force is 0. 30 minus 30 is 0. That's why the dresser will not move. The forces are in opposite direction, same amount of force, right?
Yeah.
Okay, good. So, when do we add force?
You add force. You add force
Hmm.
when you want something to move
Okay. No.
or stop.
We add force when they are in same direction. Like these two guys are applying force towards right, both of them. So same direction force are added up. Okay.
But you said why do you add force?
Actually, I think
You
you didn't hear it properly. I said when.
yeah. When do you add force? When you want to move something.
Okay, okay, yeah, that is also correct answer. But I wanted to ask regarding the direction. So I'm just giving my answer also. Okay, that's also correct.
Okay.
Uh, so what is net force?
Net force is the combination of like all forces, I think.
Exactly. The combination of all force is called net force. Suppose there is
Okay.
an object. Okay, you apply first F1 force, which is 5 Newton. The second force is applied from the bottom towards upward direction, 5 Newton. This force is applied towards right, which is 10 Newton. This is applied towards left, which is 10 Newton. Let me name it F3. This is F4 and this is F2. Okay.
Okay.
So what is the net force on this object?
Hmm. Net force on this
If you check,
is
hmm,
5,
see same force in
15, 20, 24.
20. Okay.
4 newtons.
Actually, it would be 20 if the directions would be same. But you can see one force is going downward, other one is going upward. So these two forces, like one is going like this, 5 Newton, other one is going like this. They are same and going in opposite direction, so they will cancel out each other. Similarly, this 10 Newton, this 10 Newton, they are in opposite direction and
That's
same
10
amount.
newton.
Yeah, that's 10.
You put F4, F3, F2, and F1.
Yeah,
Like
F3 is this.
I understand that the F1, the 10 9, and the 5 9, but I didn't see the 10 9. I thought the 10 9 was just the same as F1 or something.
Oh, okay, okay. Sorry for
Then
that.
what means the whole thing's zero? The thing's
Exactly.
zero,
Very
cause
good.
all of it's going.
Very good. Absolutely
Uh,
correct. Absolutely correct. The
mm,
net force is zero. That means the
yeah,
object will not move, right? Because
yeah.
when net force is zero, there is no motion.
Okay.
Yeah, like in this case, these forces, when they both apply force in this opposite direction, and the force amount is same, like if this is applying 10 newton and this guy is also applying 10 newton, these kind of forces are called balanced force. What are
Yeah,
they?
balanced force
Very good.
is.
So yeah, when the direction is opposite, we subtract them. Okay, when the
Okay.
direction is same, we add them. So like in this one, but sometimes they may be applying force but they are not equal, like this is 30 newton, and let's suppose Sam is applying 30 newton, Harry is applying 25 newton. So basically what would be the net force? 30 minus 25, how much is that?
Okay. 30 minus 25. Oh, 5.
5 newton. Good. Why I'm
5.
subtracting it? Because they are in opposite direction.
Yeah.
That whenever the forces are in opposite direction, we subtract.
Yeah.
And this that means the dresser will only move with 5 newton of force, and in which direction? In 30 newton force direction, because the force which is greater, that will help it to move, right? 30 newton is greater than 25, so that means it will move towards right, like in this direction, because this is 30 newton and this is 25 newton in this direction. So the force will move with 5 newton of force in this direction, right?
Yeah.
Very good. So sometimes, have you ever played this game tug of war?
Uh, actually, no.
No.
But I do know it.
You know
I
it.
do know it.
Okay, okay, that's great. Yeah, that's what I wanted to ask basically. So if you know about it, then basically,
It hurts my hands.
okay,
I actually haven't played it, but I have seen people rip their arm skin.
yeah, if yeah, sometimes this rope is, so sometimes during this game tug of war, the rope does not seem to move to any of the side, even if the children on
Yeah,
both sides, they are pulling it really hard, but it does not move any of the sides. Why does that happen? What do you think?
because both sides are kind of equal.
Exactly, when both sides force is equal. And what is the direction? These guys are applying the force towards right, and they are applying force
Yeah,
towards left. So is it same direction or opposite direction?
opposite.
Opposite, exactly. So that means these forces are balanced or unbalanced?
Did you hear me?
No, no, I didn't hear.
Okay. Oh. Okay.
What
Now
happened?
did you hear?
Let. Oh, what did you say? Can you
Oh,
please?
I said okay. I said okay. I said okay. Yay. Oh, I needed to see if you heard in the chat. Cause my thingy, this thingy, is supposed to make my words louder and clearer for the other thingy.
Okay.
For the other person. I'll
Mm,
test that out later.
yes, I was asking, is this an example of balanced force or unbalanced force?
Unbalanced.
Why unbalanced? Because I said it is not moving, in which case the motion does not take place. Balanced means same amount of force in the opposite direction.
Okay. So it's
Unbalanced,
balanced.
exactly, it's balanced. Good. Unbalanced means unequal force. So in balanced
Yeah.
force, the net force is
The net force is equal.
zero. Forces are equal on both
Yep.
sides. For example, if it is 100 newton by all these three guys and 100 by this, So 100 minus 100 would give you 0. That means net force is 0, right?
Yeah.
So in case of balanced force, does motion take place?
Mm,
No, right?
yeah.
No, they are not able to move it because
Oh,
the forces are balanced. Balance means same both sides.
okay.
And the net force is 0 in case of balanced force. Okay?
Okay. Okay.
What is balanced force?
Balanced force is equal.
Very good.
Unbalanced force is not equal. This is equal height. This is unequal height.
Mm-hmm.
Balance is like a rock and a stone.
Hmm.
That's the same thing. So if you have 100 kilograms of feather, 100 kilograms of rock, which one's heavier?
100 kilograms, both of them are same because you
Yeah.
already said 100 kilograms. So obviously you would have to put a lot of feathers to make it 100 kilograms, but the
And so do you have to do with rocks.
hmm,
But not as much.
yeah. So
They're
basic
balanced. But if I had 1 kilogram of rock, but 10 gram, 50 gram, 120 grams of feathers, the rock is unbalanced.
yeah. Okay, good. So what did you understand on this slide?
I learned that balance and unbalance can be used for different reasons. Like if you had force, like if the sides are like equal, you don't say it's equal. You call it 0. And I figured out what Newton was. I already knew who Isaac Newton was, just the type of gram thingy or weight.
Mm-hmm. Okay.
And that's all.
Yeah, but I'm talking about this slide. Only this slide. What did you understand over this slide? What did I explain?
Uh, and the thingy, like the both teams, like forcing on the opposite direction. This team with the team without the hat,
Hmm.
the team without the boy with the hat,
Mm-hmm.
is pulling it this way. This way.
Hmm.
And then the one with the hat and the blonde hair is pulling it this way.
Okay, yeah.
And um
Why this rope is not moving?
because it's a picture and because both of the sides are equal.
Very good. So read it.
And net force on an object is 0. The forces on the object are called balance forces.
Yeah.
An object subjected to a set of balance forces does not move.
Hmm. Okay. And what are unbalanced force? Read this.
Net force. So this one is 50 newtons. The other one's 38 newtons.
Exactly.
How is the girl's side higher and the boy's side lower?
Yeah, it can be, isn't it? It could be.
Kind of. Yeah.
Hmm. So don't
But what
underestimate the power of a
the
girl.
girl has a older sibling. Like these 3 boys might be in like a middle school. One of them looks like they're in like seventh or eighth grade.
Mm-hmm.
That's not fair.
Okay. So I think you are on boys' side.
Yes.
Mm.
But it's a picture. So
But the
technically, it could be made up. It could be like even Steven right
because
now.
mm-hmm. So the winner is girl side.
No, it could be even Steven.
Okay.
Maybe the person who made this was a girl and she wanted to prove that girls are better. So she did this.
Yeah, I was also thinking the same. Okay. So when the net force is
It's cute.
not zero, here the net force is like
Yeah.
50 is in this direction, to 38 is towards this direction. So the directions
Yeah.
are opposite, so you would subtract them. And the total force
Yeah.
would be 12. So the net force is not
Okay.
0. So they are called unbalanced force when net force is not 0 and the motion take place here.
Okay. Yeah.
So there are two teams. Can you tell me which team will win the game? How would you
Okay. I
find
really
that?
want the hat. I really want the hat team to win.
Okay.
So 63 plus 32 is 95 plus 95 is 95 plus 26 is 118.
No.
100 and,
100.
no, 121
Very good.
Newton.
Hmm.
46 plus 35 is 81.
Hmm.
81 plus 29 is 100. Yay, the hat team won.
Yeah, this one is 110. So this cap one, this team is winner.
Yeah.
Hmm. Good. So here the is this an example of balanced or unbalanced force?
Mm, I think it's unbalanced.
Very good. That's why the motion is taking place, right?
Yeah.
Yeah, so this team is winner. Okay, that's great. So um, can you summarize what did you learn today?
Today I learned about what newtons are. I learned what
Okay,
balance and unbalanced
let's start with
forces are.
force. First, tell me what is force.
Force is a push or pull. A push or pull. It can be an up,
Hmm.
down, left, right,
Hmm.
diagonal.
Yeah, the direction could be any of the direction you are saying this. Okay. What are the effects of force?
The effects of force could be like could be like making it go faster, making it go
Good.
slower,
Yeah.
making it go, making it go, making it move, making it stop.
Hmm. Perfect. Very good. Or it can change the direction also, right?
Yeah.
Very good. That's great. Uh, what is net force?
Net force is like net force is oh, I know net force. Net force is a combination of all the types of for like what's it called?
Combination of all forces that is being applied on an object, right?
Okay, yeah.
Hmm. Good. When do we add force?
You add force when you want to push something, pull something, stop something,
Wha-
stop something, make it go faster.
Yeah, but when the directions are same, right? Yeah, that we
Yeah. It's
okay.
zero.
What is zero? When we subtract,
The Newton. The Newton.
the force is 0 when there are balanced force. The total
Yeah, you
force.
said balance. That's why I said balance.
Yeah, okay. Good. Any question?
No. But look at the
Okay.
chat.
Oh,
Ta-da! It's Mr. Snowman, Mr. Jupiter, the moon.
okay. Mm-hmm.
No, wait. Yeah, the moon. Flying money. New moon with the face. Comet. And then
Mm-hmm.
skull.
Okay. So I'm sharing a worksheet in chat, okay? That would be
Okay,
of
do I have
homework.
to do it now?
Yeah. You can do it.
Why?
No, I mean, you have to do it before your tomorrow class, okay? And don't do
Okay.
it at the time of the class. Like, just give me 5 minutes. I need to go to washroom, and then you start doing it, okay? Don't be over smart, okay?
You like my letters? It's
Yeah.
called the Prime of
Which
Language.
language is this?
The Prime of Language. It's a new type of language. And there's another thing called Buff.
Okay.